So today we're going to be talking about leveraging private networks for a digital campus. And I'd like to introduce Bill Britton, the CIO from Cal Poly.
Thank you very much. I'll give everybody a chance to get seated. Thanks for coming. We appreciate it. First of all, Scenic, thank you for inviting us to speak here today. And thank you for the 100 gig that you bring to the campus. Without it, we would be stuck. And we really appreciate all the work that we've had in working with you. And as a former POP, we also appreciate the great work that you've done in helping us not be a POP any longer and moving forward from that. So thanks very much. We're really here to talk about digital wireless. We started off with a 5G project and we've seen it expand significantly. So what I thought I would do is kind of prepare you with a background. What have we done at Cal Poly? And then I'm going to turn it loose on this august group of people to really help out. And with that, I'm going to turn to our tech lead, John Polly, to kind of introduce himself and introduce the rest of the members on the team.
Good afternoon. Happy to be here. I'm joined by this esteemed group of panelists that have been accompanying us on our journey as we stood up this 5G lab over the last 18 months. I'm the Chief Technology Manager for the 5G lab, our digital transformation hub and new programs at Cal Poly. We've been at this for about 18 months. As I said, my background's actually in the energy industry. I'm not from academia. I'm not from the telco world. I actually did private wireless in oil and gas fields for some time as an architect. Over my career of 15 years there, but very much enjoying this new domain. To my left here, we have Carl Temme. He's the Vice President of Federated Wireless's Products Division. Andrew Wiedlea is a network engineer with ESNet in Lawrence Berkeley National Lab. He's supporting them and really has an eye to driving private wireless out into the field. Really great working with Andrew. We have a lot in common from our shared backgrounds. And Michael Usher is joining us, a network engineer from UC Santa Cruz. Similar pain points we've been enjoying this week, sharing stories and opportunities for private wireless. We've been aligning and forming a coalition, sharing pain points and opportunities where private wireless can help address that last mile across the spectrum, high band, mid band, low band, private, public working together, roaming, and a lot of different incarnations of how you could combine these technologies. So we'll get into it a little more. I believe Bill is going to go through an overview of kind of where we've been, and then we'll get into some questions, answers, and just a discussion.
All right. Any Cal Poly SLO alumni out here in the audience that I can remind you what the campus looks like? We've advanced quite a bit. I always like starting with this chart as part of the discussion of what our problem set is. It's a beautiful place to live. It's an amazing place, a little expensive, but that's California. If you look around, mountains to the top of the screen, all the way around, we build buildings that are concrete, 24-inch thick, glazed glass windows, at least 2 inches, and lots of steel. They make great RF attenuation. It's more like a Faraday cage, and that's part of our challenge. We have currently 2 locations, one on campus, not in this picture, we'll show you in a minute, and one other one in the city. That's our 2 cell tower spots, 2 cell towers for basically the entire region. So we have lots of challenges with that, particularly getting signals into the building. So just a little overview of who we are and what we're doing and why we've begun this journey and how to expand out on it. And then I'm going to turn over the panel to really go deep dive on the technology and the other things. I'm just here to make it look good. So we really wanted to look at these very important data points. We're trying to figure out how to remain more robust on a campus, how to really adapt faster. As you know, on a campus, the demand is ever growing. We did a day in the life of the university. We picked a Sunday. We wanted to see what was going on with the students and how much was being utilized. In a 12-hour window, now we went down in this utilization study, we went down to the component, to the device level. We found a student who was using the Xbox as a geospatial server for a game for 1,500 gamers on our university network. And in a 12-hour window, that student downloaded and pushed 1.7 terabytes of data across our network. If that student did that same thing on the day of registration, we would have melted. We would have stopped. We just could not hold that kind. And so we started immediately as the CIO panicking because what do I do if, and this kind of condition is ever increasing, the demand for information. And we talked to several entities about what would you recommend, and it was really interesting because their comment was, oh, well, bandwidth shaping, bandwidth restriction, that sort of thing, but always the word shaping or restriction or lessening. What was interesting in that, in the exact example I used, they said, well, that's gaming, so you can just cut that off. The unfortunate part is I now have professors who are teaching gaming theory, or how to write gaming. It's part of the curriculum. So I can't cut off what used to be the old world of, well, it's not important, so just cut it off. So using all of that has really become a challenge. The other thing, as I mentioned, in the neutral host networking implementation, we make it as hard as possible on ourselves. We have a brand new building, the Frost building. It is over a $200 million technology-based building. When you get in the building, it drops to 3% cellular coverage inside of the building. That pushes all of that cellular traffic onto our Wi-Fi, which then, of course, is limiting what we can put across the Wi-Fi. And we have classrooms and labs that are dependent on that lab Wi-Fi access. Bandwidth slicing is something we want to take a look at. So is it really doable, possible? And we'll talk about that. Digital campus transformation. So I know every campus out there is talking about digital transformation. And what I've seen is everybody other than IT, their concept of digital transformation is throw it on the Wi-Fi. I've got electricians, HVAC, all those systems, and they just said, well, give me a Wi-Fi point, we'll just tie to that. We even had one element tied to our power plant where they just put it on a public IP. Not good, not safe, not smart. So it was really, how do we address those kinds of things in this digital campus of the future? So the 5G lab, we went out and we started asking questions about 5G. We attended several conferences. It was really interesting because in each of those conferences, the use case being described to us was more from a vendor relationship to us, a productized solution set. It was more along the lines of, here, let me build something for your football stadium. Let me build something for a specific instance. And what we kept asking was, where are the use cases, particularly in the CBRS arena, that allows us to look at it as an application just for what we do, ramping up things like technology, research, other things that really adds what Jonathan refers to as an HOV lane to our existing networking capability. And so we started off with a single node. This is a picture on your left is our radio signal hill, which is where all of the antennas are for the region. It's actually on Cal Poly campus. So we own the fiber line up to it. We own the property, and we then lease it out, which is where we start off with. Is a great point because we'll come to it later, but it gives us quite a view of that entire region I showed you in the original picture. The antenna, which is represented here in the picture, is the first node that we put up. And when we first put it up, what we saw was something very interesting, which is that 5G didn't have many vendors who were building components for the network. And that we found very discouraging because we were trying to figure out how many things can I connect to it. And you had to have a very specific connection to integrate into it. So under that, we got a little discouraged until Apple in the iPhone 15 and iOS 17 and above put in 8 eSIMs into the phone. Each of those SIMs can be used to connect to the 5G network. They'd actually designed it with the concept of a private networking involved, and now we're able to take advantage of it. Jonathan, you want anything in that first tier?
Yeah, in terms of what we saw with the 5G standalone network that we rolled out, we wanted to understand the space. There's a ton of hype around it. Private cellular has found a foothold in factories, automation plants, and the like in the private sector and enterprises. If you have a heterogeneous environment in terms of a campus, there's all kinds of crazy use cases. It's a challenge to find the right devices. If you're a factory floor or a warehouse, you have one or two devices and then you just work. So it's been a success. Fortunately, our timing worked out great. About 6 months after we got this network up, Apple came to us with iOS 17, and they've always had an ear to enterprises, and enterprises were looking to bring their iPhones and iPads onto their private networks. And so if you look through the dev documents, you'll see support for slicing, end-to-end slicing on a 5G standalone network. You'll see support for geofencing. All the things, our wish list came true just after we put this up. And Apple was very happy to have a voice of a customer ready and willing. We already had a great relationship. So we're working with their engineering teams and able to test and work on eSIM provisioning, deprovisioning, and what these workflows look like. So that was an early experience with this first iteration, was a dearth of devices, rapidly closing that gap with Apple and saying, okay, this does have room to run. It's maybe not where we wanted to, but that gave us a lot of motivation and insight in terms of where we could take this technology.
So the first node deployment really gave us a lot of lessons learned. It really was for us the prove it, learn by doing, which we kind of live by at the university. And it gave us opportunity to really ask some deeper questions. Carl is at Federated Wireless, our partner in this, along with AWS. Carl, could you just kind of iterate a little bit on that first initial node and what we were shooting for and what we ended up with?
Sure, happy to. So just for context, so we're talking about private 5G. Private means you own it. You, the network user, the enterprise, Cal Poly, it's yours. You can incorporate it into your enterprise network. You control where it gets put. You get access to all the data. That's a private network. 5G means, yeah, it's the technology that the telcos use made accessible to you, Cal Poly, or whatever the enterprise is. And so to have that technology be accessible, a lot of the network functions are being virtualized, things are being scaled down. Spectrum, you need access to spectrum, not just unlicensed spectrum like Wi-Fi is used to running in, but you need access to carrier grade spectrum. That's one of the things that Federated Wireless does, is anybody who's accessing carrier grade spectrum in the CBRS for 4G or 5G technology, they get access through our system. So we have about half of the traffic, CBRS traffic, going through our system. And so when Bill and John came to us and said, hey, we want to start implementing this, we said, okay, well, let's start small. And so we had the one indoor radio and the one outdoor radio, and a packet core, basically like a telco would have, a packet core running in one of their server areas. And that's where the journey started.
Thank you, Carl. So from idea to inception to deployment, how long?
3 or 4 months. Yeah. The actual, setting up the radios in the network was a week, sort of figuring out where do we want to put it? What use cases do we want to enable? Was some of the process. Anything you want to add to that?
Yeah, Bill had commented on really putting this out there and starting to discover where the use cases existed, and talking to some peers at the conference. They're looking at similar opportunities. Where are the use cases? Is the technology chasing a problem? Where are the real problems? We knew that Cal Poly was blessed with a very diverse set of challenges and opportunities given the dense nature of the campus. What you didn't see in that picture was kind of the south side. Traditional looking campus, sports fields, buildings. The north side is test centers for agriculture, cattle, poultry, swine unit. Strawberry Center is up there. And so from that hill in that picture, just one antenna facing north, I could hit half a dozen opportunities, use cases, cattle tracking, monitoring, support the Strawberry Commission, robotics in the field for picking. So it was a very low cost investment to just get moving. We learned where the strengths are, we learned where the weaknesses are, and we'll continue on in terms of the evolution and how we took that learning and continued to iterate. I think we found about a 6-month cadence, I'd say. We found that from concept to deployment, we're running at about 6 months, and each time we kind of take that input, we work with our partners, and we figure out how to go forward from there. That's about the right, because there is an infrastructure investment in this. It takes more time. We're not just writing code and software, like our experience with AWS and the cloud with the DX Hub, but we're probably on our 3rd or 4th iteration now, and each time we learn a little bit more.
So the joy, again, is trying to figure out, as a polytechnic, how do I satisfy all these different users? And that's just the biggest challenge that a CIO has at a university, is the disparity, the differences, the technology debt, all those things that you have to figure out. This is our chance to try to get in front of it in this modern networking. Here's our Frost building. It's absolutely gorgeous inside. Every room is a lab classroom in it. Single donation, absolutely amazing experience. I think we have 175 WAPs in the building just to keep the Wi-Fi alive. 175. So I started looking at things like future costs of changing those out for the next versions of Wi-Fi and everything else. And my pocketbook melts, my head, I cry. You know, it's a horrible feeling. The other thing is this building had a 3% cellular coverage inside of the building. And the first floor, as Jonathan reminds me, because it was hardest, is a subterranean floor. So it had like a zero experience. We were able to take and test and evaluate the next condition, which is use of a neutral host in a private network. So with T-Mobile as a partner, we were able to work and develop a neutral host concept and prove and validate. And that building went from a 5% or less coverage signal to 95% throughout the entire building interior, which means all of that cellular traffic, instead of jumping on the Wi-Fi, we can now deny it. It stays on the cellular, goes to the provider. The access for that has been absolutely amazing. One of our favorite stories is Jonathan was actually doing a Zoom call with us, and he was in his truck. He got out of the truck to go inside of the building. As he went into the building, the signal for the Zoom signal increased in clarity. We all saw a visual difference in that capacity of the delivery via that moving to that 5G. And of course, he's a T-Mobile user, so it was a really good test case for them, but it really helped us out. Jonathan, anything else on this, the complexity of this project?
I can give you a little bit of a technical overview. We use this Frost Center for Research and Innovation. It was a unique building because it's the convergence of things like agriculture and advanced research and marine research and food sciences all into one building. It's at the core of the campus. It's kind of this converged center of academics. And in a way, we're trying to use it as a demonstration site for converged wireless. We're not trying to replace wireless. We're trying to be additive. We're trying to add spectrum to the equation. CBRS brings us clean air. We can do things like slicing, so we can go end-to-end slicing from the core to the radios to the handsets with Apple and say, okay, well, this is for the neutral host or this is for operations. So this has been kind of the fulcrum of our deployment to really try new things out. And the neutral host has been a killer feature. And I think this is where anyone that has a campus has this pain point, and that's why I'm glad Andrew and Michael are here. And at some point they can share their own pain points around it. But
yep, I promise we'll get to you guys. You're not up here just to make us look good.
Can I just add one thing? So neutral host, we're saying neutral host. Probably a lot of people know what we mean, but just in case. So neutral host means take that same private network. So Bill and John, they own the network. It's a game changer because it turns carrier service, T-Mobile, AT&T, Verizon, into an app that runs on that network. So instead of deploying separate infrastructure for each of those carriers, they can borrow the private radio network as an access mechanism for their subscribers.
And as I said, we have two towers, and that's all carriers on those same two towers in our region. What's interesting is the answer to improve performance on campus is let us put up more antennas, but you have to support them. You provide power, you do maintenance and support on the tower itself, and we'll take care of the antenna. It's not a tenable solution for us long-term because now I have multiple things I'm worried about, but I don't own, I don't operate, I don't control, and I'm still not getting that internal coverage inside of the facilities like we need. So this really was, as stated, a game changer for how we can now approach facility usage, modernization in those facilities, data usage in those facilities. And we'll talk about some other things that add to that in the private network. John?
Yeah, there was one more data point that people find interesting on the Frost deployment. And we went in trying to ground truth. Okay, what is the ratio in terms of densification from WAPs to these indoor private 5G radios? 1 to 10 has been advertised. With a building like that, we saw 1 to 5, but that building had 170 WAPs. It's not a big building, but the way it's constructed is so dense. So there is a story to be told around, what you can do to get penetration with these CBRS radios and using private cellular instead of Wi-Fi. But that's a fun fact. 170 WAPs for a 4-story building. That's really not that large.
Not fun. As the CIO, of course, I'm worried about cost. And as I said, the cost growth and all those sorts of things. So here's a really good example where we had an actual user that had significant requirements, and we were just not able to really add value to it, mainly because Cal Poly has a steel pier. It's about a mile out to sea. And on that, we had a T1. And earlier talking to one of the scenic engineers, he reminded you that's 1.444 megahertz. So that means email won't work. Not many other things are going to work on that. And they're doing education. Those buildings are educational buildings, actually go down. And they have SCADA equipment on there for freshwater desalinization projects that are tied to the aquarium that are in the bank. So they're pumping water back into that. So all this data requirement on a T1. And what we found out was that they were putting a lot of data for their analysis, their research on thumb drives and bringing them back to the campus, which, that's like the second scariest thing other than a big topic for security is to hear that you've got a bunch of users bringing thumb drives back with data on it and not really sure why or how. So what we want to do is a couple of things with this one. First, we wanted to see if we could get a node out to the pier to utilize. What we were able to also evaluate was replacement of fiber. So we did not put fiber out to this facility. We actually shoot it. The picture there with the guy in the cherry picker is the individual putting the antenna up, and Carl can give you all the technical data on that. But then we shoot that directly from that antenna out to an antenna on the pier. The pier then uses bandwidth slicing. So we have Edgerome going across. So there's a commercial drop provider that then shoots across that we then have Edgerome out at the pier. We found out how successful it was and that the pier had an open house. And we found, this is right as we deployed this, we were hoping we'd get it up for the open house. Not only did we get it up and using, we found out the students were showing videos of the whole project on the pier. So they're doing streaming video with this signal out there. I'd say it was a big success. So using a commercial provider, we went to 300 megs, which is a 300-fold increase over what we had. Jonathan, anything else you want to add to that?
Yeah, that was, I talked about slicing. This for me was really wanting to go deep on the 5G capabilities for private slicing. The carriers advertise slicing, so you can buy a slice of their network that's kind of your slice and into the core. Well, you can do it on a private network too, in a cellular network. So we could carve off our traffic. And you can only do this with a 5G architecture, not the legacy LTE or 4G. But a slice that was supporting that SCADA system on the pumping system, segregated from the traffic that might be used for the public. There were 2,000 people on the pier for that open house. It's a big event. And then traffic for, the learning. There's a classroom, there's Zoom sessions, remote learning experiences in the lab. So as an architect, having this new toolbox of wireless capabilities to get the right technology to the use case, this was a great place to focus on our three pillars of operations, student experience, and R&D. There are always experiments being run at the end of the lab, and they're not monitored, or they hadn't been, but now we have capabilities that let those scientists that are often in other parts of the world check in on their experiments, and that's where we're going with the pier.
Carl, you want to add what we did differently on this one as well?
Well, one of the things that's interesting is you saw where we started the journey with those two radios, the one on the radio hill and the one indoors in the technology park. And what Cal Poly has evolved is this hub, this communication hub, where the packet core, sort of the core of this private telco network exists. And what this showed is that you could detach this site that's remote, that's 10 miles from that hub. You can attach radios back to that hub. And that was a really interesting sort of new capability, because it opens up the possibility of, what other remote sites or what other sites around campus does Cal Poly want to connect? So I think that was one really interesting and
absolutely
great thing.
And at this time, Andrew or Michael, do you want to add about why this is applicable in your world?
Yeah, absolutely. And this is where I think our interests really come in. This idea of being able to throw your wireless infrastructure anywhere in the world you want and have it remain tied to your own core is really enormously powerful. It changes the whole idea of what a campus is, in terms of sort of how you can deploy services and maintain sort of first-class access to scientists or researchers wherever they may be in the world, provided you're operating somewhere where you can get access to CBRS or other dynamic spectrum. So from our standpoint with ESNet, we have a national and international fiber network, this backbone. But how many of you right now are actually connected to a wired connection or an optical connection? Right? No one. right? So there's this, we all love fiber, but fiber and cellular are completely peas and carrots technologies. They belong together, right? Where you have one, you ought to have the other. And you now finally have the ability to deploy private cellular instances that are tied to your mission, that stay in that keep everything in your information space, that may be tied to your identity management processes, and to deploy services in a way that simply have not been capable. So from our standpoint, we're framing things. We're in the process of deploying similar capabilities, working with Federated and other folks, both at the Lawrence Berkeley National Laboratory site, but also we have a field research site in Colorado that I'll talk about more in the next talk that I'm giving next door after this.
Sure.
But I had to put a plug in, right?
Just a small pitch. Go ahead.
Yeah, right. But I think if you think about this, like where this changes, this is a game changer for what defining what the Cal Poly campus is right now. What John and Bill can do is basically they can tie together places like this pier. They also have properties out the Swanton Ranch north of Santa Cruz. That's this 3,000 acre potential future environmental research site that has absolutely no coverage. We were up there yesterday. There's no commercial carrier coverage. You're right off the Highway 1. You're 60 miles south of San Francisco, and there is no coverage at all, right? And that's not atypical. There's a lot of this world that commercial cellular doesn't exist in. And even in cases where it does exist, you still may want the option to keep devices and sensors and scientific activity tied to your packet core so that you can tie them into your compute and storage and other resources. So we're very excited about what this means for us because we're operating sort of everywhere, but we never have fiber exactly where we want it in terms of being able to provision, say, remote field sites. And we're working sort of in this same kind of way. But anyway,
Thank you. Michael, you want to add?
Yeah, I'd be happy to. So I think one of the things that Bill said earlier was the word convergence. And I think for us, that's an extremely key part of our investment decisions. We're facing a lot of the same challenges that Bill's addressed on our campus. We have a number of different use cases, and we were starting to converge on 5G as a solution that we were looking into. And then very conveniently, the connection was made. UCSC and Cal Poly started collaborating on planning how we could take the model that they have developed, both indoors and outdoors, and start looking at how we want to apply that to our particular use cases. So we also have remote sites. There's a sea lion habitat at Año Nuevo that is managed by UCSC, and that's probably going to be our pilot outdoor project. There's also the main campus itself. We have major challenges around coverage there. We have a huge campus, and we cannot flood that with Wi-Fi. So we need another solution. Right. 5G has technological advantages over Wi-Fi. But the problem has been in the past, the carriers, Verizon, T-Mobile, AT&T, we have a tower on campus. They have antennas up there, and it covers a portion of the campus. But we constantly get students complaining. Why does it suck? The carriers know this, but they can't invest the money in building out that environment on our campus because they just don't have the return on investment.
Right.
Now, in our case, because we've got other benefits that will come from building out a private 5G solution, with the neutral host component of that, we can extend the T-Mobile, AT&T, and Verizon coverage wider on our campus and possibly at other remote sites like Año Nuevo. There's also Big Creek to the south of here, which is an A&R facility, but UCSC looks after the networking services there. The 5G technology provides some real benefits in those remote locations and also on campus. And it's compatible. When you deploy it in a way that is harmonious with your Wi-Fi deployment, they can support each other very effectively. Yeah. One of the worst things for Wi-Fi is people distant from the AP trying to get on, and they get on at a very low data rate. They consume a ton of airtime, and it's very wasteful in resource. And yet, if we had a wider coverage 5G solution, the device they have has probably got 5G capability, and they would flip over to that, get a better experience, and they would improve the experience for other people on the Wi-Fi. So they work together. It's really about that convergence and designing a network solution that takes the best advantages of all these different pieces. Now, the thing that I really love is we're not going to do that proof of concept. I've got someone else doing it for me. So all I need to do is look at how the solution that Cal Poly has worked applies to my environment, and then take a cookie cutter approach and build out a similar solution.
Thank you. And that's been one of the things that we learned. We also have a cloud innovation center that's a partnership between ourselves and Amazon Web Services. And we learned in that experience about how to create the OpEx, the operational research evaluation concept, and really boil that out so that we're creating solutions that get published, that really talk about how would I do this again? And so we're using that same experience as how Jonathan and the team run the 5G element, is that, we're really trying to document. Now, one of the areas that, again, as a polytechnic, particularly in the state of California, we're really concerned about is the world of ag tech. And everyone that we interview in the ag tech world says the number one challenge is connectivity. And even though we've got, Starlink into tractors and John Deere now, that connectivity, that data is not democratized. And we're seeing a really disparate approach. There is a ton of new starts of AI and other elements in the ag tech world, but the key becomes how do you tie it together and make it mobile enough? So we're working on a 5G CBRS private deployment with AI devices in the ag tech field. The good news is that tech field is right behind where we currently have our situation, so we can test and evaluate it there. The device you see that has 4 tanks on it, or 3 tanks on it, that's a robotic strawberry picker. Strawberries is a $3 billion business to the state of California on an annual basis. So it's a very high priority issue for the state of California. The California Strawberry Commission is co-located at Cal Poly. And so we're going to be working with them to really tie that private 5G network to that robotic device for the field. One of the other things that we find out is that field safety is a huge issue when you're in the middle of a field in the middle of nowhere with no cellular and somebody gets hurt. What do? Anybody farmer? You put them in the back of the truck and you take them to where you get a cell signal. So again, the idea is how can we increase that connectivity in the field and utilize it for all these different ag tech devices? And what we're looking at, is there a possibility that we could use AI in the world of sensor connections, using 5G, using edge compute, that now we can really enhance what the ag world is able to do with that field. And so that's one that will be kicking off in May. John is the lead for it, and we're really excited about where that's going to go. And our ag school is extremely excited as well. And we've gotten the interest of several non-ag entities, such as Apple and others, who are really looking at this as yet another yield for us. The other one, for everybody that has a university and you have graduation, particularly summer graduation, we melt down every cell tower in our area. Of course, it's only 2, but we melt them down. We watch the meter go to slow, because in a 2-day period, we have 55,000 parents who are all taking pictures of their son or daughter as they cross, and they all want to do it at the same time. And we just shut down, and I get letters of complaint that our cell service stinks. That's not really mine, but we're trying to look at, is there a potential for 5G to act as an off-ramp, something that we can do, something that we can utilize to really help us move to a different way of supporting that, and possibly even creating an application-based system so that that app on the iPhone, you would possibly buy guaranteed bandwidth time to take your picture of your child cross the stage and use that. So we guarantee you access, and I don't get any more hate letters when it comes time to cellular service. So panel members, it's changed a little bit, so I'm just going to shoot past that. I'm going to put this up, and I'm going to ask now Andrew to kind of talk about what's next and what are you doing in this particular area?
Yeah, thank you. So, I think where we're at is we're at the point where, the immediate benefits of deploying, say, a private 5G CBRS neutral host system, really are sort of about replacing DAS and sort of changing the relationship with carriers within your campus space. And that's very interesting. At ESNet, that's less focused to us because we are really more concerned about what happens sort of offsite, the different laboratories that we serve as interconnect customers. And we're interested in making sure that science can happen sort of anywhere in the world that it needs to happen. So I think for us, it's, this testbed and this collaboration has been really important for understanding kind of the where this technology is, as well as understanding the use cases in terms of equipment available. We are at a point where sort of availability of equipment for end user devices is really just about to explode. It sort of feels to me like things got held up a little due to COVID and supply chain activities, but the new Qualcomm RedCap reduced capability chipsets are starting to become available, which really lower the cost of say USB dongles and stuff like that allow you to put Raspberry Pi type devices onto cellular networks much more quickly and efficiently. And those are all being set up to run on band 48. Many of them are being set up to run on band 48, which is the CBRS dynamic shared spectrum space. So, as this starts to become available, where you have, say, a chipset at the $30 to $50 price point, the amount of devices you can now throw onto your private cellular network start to really explode, and that's really exciting. So for us, it's been kind of a voyage of discovery where not only are we working with the folks like Federated and other folks to deploy the same kind of system that Cal Poly is deploying, and understanding how we might use that to both expand coverage out in the world, but also possibly as a way to provide services to individual lab sites as well. But we're also looking at things like non-terrestrial networks. We're looking at LoRa. There's increasingly sort of tools that are kind of advanced wireless fusion devices where you're running LoRa and cellular, say, off the same access point. There's a lot of hardened equipment that's starting to become available, particularly as military and security applications for private wireless networks start to explode. What that means is the supply chain starts to open up. So Jonathan and I were at Mobile World Congress a few weeks ago in Barcelona, which is really, really a tough thing to have to do, and we deserve your sympathy for. But it's really striking the amount of cellular base stations in a backpack that are starting to become available. Like the whole cost of deploying your cellular system and the options available and for running things off solar panels or running things in resource scarce environments, running things on top of mountains, with ruggedized equipment that's potentially affordable. And maybe even having that tied into things like LoRa as sort of a single solution, that's all changing. So as in terms of folks on the REN side of things, I serve my customers, and I know that there's use cases where those things will start to become more and more appealing, and we're going to see a demand for that. So what we're trying to do is kind of get ahead of things a little bit by deploying this equipment and this capability both at lab sites, but also in a research area we have in Colorado. And then begin to understand, okay, how do these things all work together? And that's really I think the point you were making as well, where it's not an or thing. It's, there's going to be private cellular, there's going to be Wi-Fi 6, there's going to be LoRa, there's going to be satellite, there's going to be all kinds of things, and they all need to be sort of working together. And I think, seeing the convergence of these capabilities onto something like a future, evolved packet core would be really exciting. So, I think that's also an area of interest for us. But
John, you want to expand on what we're doing there?
Yeah, there was a thought that when you mentioned our time in Mobile World Congress, how fortunate we are in the U.S. to have CBRS and dynamic shared spectrum, and the fact that we have this resource in 3.5 is unique. And so there's a lot of different technologies. There's a basket of technologies. We need to bring them together in a converged fashion to make them useful and target the right use case. But there's this ability to have this dynamic spectrum sharing, which Federated was early on in the innovation stage, lobbying with the FCC to set these rules in our institutions and research institution labs. Like the voice we have to advocate for more of this is what really gets me excited too. Because whatever technology you put in the spectrum, we need more in the high bands. We're going to start doing some work with millimeter wave for point to point. That's still a special temporary access request, but maybe in time that'll evolve. We are using LoRaWAN for the low band. That's a good solution right now. Right now, we're really in the mid band 3.5, but looking forward, the opportunities in terms of air and spectrum is really exciting, and the technologies that you can then slot into them.
Yeah, I think even I'm going to be more direct than that, which is like, okay, you guys are all here, right? The capability all depends on access to dynamic shared spectrum, right? Right now we have about 150 megahertz in the 3.55 to 3.7 gigahertz range, which is wonderful for a lot of reasons. But as sort of a REN community, certainly it's like my hope that like we'll start to work together as we identify the wide set of use cases that are going to occur to advocate for more spectrum being put into similar kind of dynamic spectrum sharing approaches. That's going to benefit absolutely everybody. And frankly, I think there's a lot of really interesting technologies for dynamic spectrum sharing that'll be developed. But I think we're sort of at the cusp of a real revolution in terms of access to really high speed and performant wireless data.
Thank you. Michael, you talked earlier today, we were talking about the need to have this capacity because of sensors that have minute energy or battery or whatever. Could you expand on that? Because I think that's really important in this.
Okay, so yeah, the commentary I was making earlier was about how there's a technological difference between the way Wi-Fi approaches remote low data rate sensing devices, actuation devices, and the way that 5G technology has developed. They've always had very different approaches. Wi-Fi is very decentralized. There is no central control. And so a lot of the protocols, as a result, are kind of inefficient because they have to allow for all of the devices in that network to come to an agreement about who's transmitting when. By contrast, GSM networks, 5G networks, they're centrally controlled. And so they're much better optimized for low power applications. And what we find is that in the research application, the sensors out there, or a couple of other use cases I've got, we have a couple of entrances to campus that are actually quite remote from any data services. We have point-to-point Wi-Fi links right now so that the security cameras located at those positions are pulling data back into the central campus. Really, CBRS would be a better solution for that.
Yep.
We also have my electrical shop wants to put power sensors in metering out power consumption by different buildings, but we don't have the ability to trench fiber optic out there. The Wi-Fi is really poor in that location. I mean, one solution is you try to blanket Wi-Fi everywhere, but it's going to require a ton of power, a ton of background. 5G has better solutions for that scenario. I think I'm answering your question.
Yeah, that's perfect. Jonathan, would you mind expanding? We talk about, and Carl too, we talk about the kind of brain, the controller behind all of this. And we've moved from the first initial snowball to something different. You want to talk about that?
Yeah, it was actually smaller than that. You might have seen the snow cone from AWS. It's like the size of a shoebox, comes in the mail with a e-ink label, and then you mail it back. It was an AWS offering. That was actually our first core. That was all you needed to get started. And I have a vision. I've talked to Carl about this. Like, we need to start getting these in the classroom where you can spin these things up, tear them down. The cloud had the idea of, your servers are cattle, not pets. It's almost the same for these cores. We need to demystify them, get them in the classrooms, get more open source options so that kids can get in, learn, experiment, break them. But I mean, we started very simple. Snow cone, 2 radios, learned about 5G. We scaled up for the Frost deployment in Poly Canyon, which we didn't talk about. And when we brought in T-Mobile and we were ready to have really serious conversations with carriers, we needed to harden. So we have a rack in the Frost Center with our R&D environment. And that was a snowball edge. And we're now evolving that further to an outpost and working with AWS very closely to unify the components in the cloud down to our edge data center, the cloud gateway, all the way to the radios. That management plane and the security plane still need some work to unify them. But again, as I've said, at this 6-month cadence, we've been iterating and figuring out our roadmap as we go. But yeah, that's where we're at now. A little bit on Poly Canyon because we kind of glossed over it. The neutral host within building with that Frost building, that's kind of easily understood, getting coverage where it wasn't. The other thing we did with that deployment was we put 2 4G radios about a mile away from that campus core into Poly Canyon. There'd been issues with assaults and injuries. It's a hiking trail that students like to go. It's Cal Poly's property. We have over 6,000 acres. We're the largest public education institution in California. And they got a blue pole out there, but we decided to say, if we can get one carrier, and we had T-Mobile as a partner, we get all the carriers for 911. That's legislated. It's a requirement. So we put service out there with T-Mobile and then tested with every single carrier, and even no SIM, could you make an E911 call? And that right there was a killer feature. Neutral host by itself is a killer feature to kind of progress getting these networks out there. But then when you have the safety component and now you can put emergency services in places you couldn't before.
Kind of point out where it is.
Yeah, if you look at the top of that screen, you'll see a set of dorms and hills rolling up. Well, back in those hills, that's still all Cal Poly, and there is no carrier coverage. And so that was kind of our bonus. We did the core, we did the neutral host in there, but we also said, let's test this 911 use case. And that requires a lot of certification and validation and some expertise to get that cleared and certified. But we did go through that. And so that is out there and deployed. And we have that as a tool in our box for us and other campuses to learn from. Carl could probably share a lot more on that, actually.
Oh, that's good. Thanks, John. Yeah, that said it well. I think some of the colleagues have mentioned, okay, we've got multiple technologies, Cal Poly, multiple vendors. How do we bring all those together? And that's what we're really just so grateful to be on this innovation journey with Cal Poly and the 5G Innovation Lab is taking this technology, creating an open platform so that they can incorporate whichever components they want to into it, making it easier to deploy, making it easier for them to see what's deployed. These are the things that will really help sort of bring this carrier grade technology to the enterprise and make it useful. And also, as Andrew said, coming from the ESNet perspective, what can you do when you put together wireless with a high-speed optical backbone? And that opens up all kinds of new use cases too of how you combine sites and how you bring new services on top of multiple networks. So this is really, we really view it as an innovation journey that it just exponentially is taking off and seeing more use cases and more ways to use the technology.
So I have two more things to say, and then I'm going to open us up for conversation with you all so that you can ask questions, or we can just stand here and look good. But, we hope to encourage you to really just throw some things at us, and curveballs are really fine with us. I'm a baseball fanatic, so I use that a lot. The two things I have left is imagine in the future if a campus, as part of tuition, could provide a signal to the student, no matter where they live in that region, that guaranteed them access to their educational material. Or look at it as a system-wide SIM that guaranteed you network connectivity for educational pursuit. That addresses digital divide. It addresses digital equity. It addresses edge computing in the cloud. It opens the door up for the university to be much better connected with every student, no matter where they are, doing daily work or research work or evaluation or any of those things. If it's application-based, you could go so far as to say every classroom, every research project would have an app that as soon as you access the app, it creates your network, connects you to your learning management system. It provides you access to your educational experience, and it's all there via your mobile network platform. So that's kind of the vision of what we'd like to do in the future. Now, we come up with these things because we have really good sit sessions and talk to each other and talk about what's going on in the world and that sort of thing. And we've kind of created a collaborative effort, but we're really pushing, and I believe the CSU is going to back us on a CSU supported structure for a private wireless connection collaboration. So this is the start of a conversation where we don't want to be the only ones holding the conversation. We want to be sponsoring it so that as we learn something and we document it, we want a place to share it. We want a place to share your problem sets and look at different use cases. And as Andrew and Michael are doing, test and evaluate things based on what we've already proven to be doable. And you do it now in your experiential area. So we'll be opening that up. There will be a formal announcement on that in the very near future on a collaborative effort around that we and the Chancellor's Office for the CSU are working collectively. With that, I'm going to kind of open up for questions. So if you've been dying to ask one, I saw you smile when I said question. So now I'm really worried, but please, I think there's a microphone or you can just yell.
I'll yell.
Okay.
The mic. We're live streaming.
We're live streaming, so they asked for the mic.
I get it.
Thank you, John.
Really intrigued by what I've heard.
Thank you.
I'm a simple country geologist, so I'll ask a question.
What can you do with all the fiber optics that's underwater and can be extended into the underwater world in terms of the connectivity you're talking about? Because we'll be mining, there's agriculture,
Yes.
aquaculture, there's going to be data storage in places that are surrounded by seawater.
Yep.
There's any number of areas that we could expand into. And I don't know enough technology to know. I mean, I understand that seawater absorbs in the wrong spectrum, of course, but that's what we were given when we landed on the planet. So what thoughts do you have on where it could go?
Well, I'm going to start and then I'll let you guys go. How's that sound? So that's why we started at our pier first, because Cal Poly and Cal Poly Humboldt are both opportunities for offshore wind generation studies and analysis to be centralized. And so we're looking at how can this help us with that discussion? How can we advance from there? So we really wanted to see that first element of replacing fiber out to our pier and get our oceanography people really, really deeply invested in our success and the desire to expand. So what we find is if we can get the academics excited, they will ask for more and they will ask us those really weird questions that we then have to go figure out. And we can't wait for that. That's exactly what we live for. Andrew, you wanted to pop up?
Sure. Yeah, I mean, the answer is I'm going to give you the coward's out answer, which is that there's a lot of answers, right? So, and that's why we have to do this sort of activity, this research and evaluation activity together as we look across this whole new technology space. So we are not far from having basically 3GPP cores on orbit in low Earth orbit cases, and that's going to support, probably not like full voice immediately, but it's going to support things like from existing handsets, like, text messages, small data messages, stuff like that, at costs that, are much, much lower than anything you're looking at now with like things like Orbcomm or something like that. So that's one set of answers. But what's cool about the ability to deploy multi-core private cellular neutral host or not capabilities much more easily than ever you could before, particularly in the CBRS spectrum space, is people are doing funky things like, so for example, NOAA's looking at like ability to say, put 3GPP cores onto their ships or onto their drones, and maybe you sail them around, and maybe once a month you sail close enough to devices that are enabled where they can dump their data onto the boat platform as it comes by. There's tons of things happening with LoRa. There's tons of things happening sort of across the different space. And there's also, interesting possibilities down the road looking at like ways to actually, use these as measurement devices as you look into, say, millimeter wave spectrum space. But, I think we've just started to scratch that itch, but we're sort of moving towards a world where, there's going to be sets of solutions that are available for data movement off places where we've never really had a place to do it.
For my part, I would say I'd love to work on that problem. There's a trap that people get into when they think about 5G, and they make it synonymous with CBRS, and it's not. 5G is an architecture standard from 3GPP, and you can slot it in different parts of the spectrum. So, like we were talking about non-terrestrial networks, I think that'd be really fascinating to work on in terms of aquatic use cases. I know that there's a startup out of Australia. We've been flying drones on patterns across agriculture for some time. It's just set it, forget it, it does it. That's now starting to happen under this, on the sea floor. Routine autonomous operations that are doing the same thing repeatedly, different sensors, different mechanisms, but the principle in the data capture is going to grow enormously as it becomes commoditized and cheaper, and everyone's doing it. So building solutions using 5G architectures would be really exciting to work on.
Yeah, and stuff like small cell technology. Yeah. So access points that can either, if they have access to their main packet core, they use that, but they also can operate in a sort of an emergency mode on a core that's on the device itself. Or also make things pretty interesting from the standpoint of autonomous vehicle operation, and being able to sort of gather data in ways that you can't currently. But John's, CBRS and 5G are not synonymous in the private space, and there's going to be a lot of frequency options available, and financial arrangements make those possible in ways that really aren't possible now with sort of the incumbent structure that we have.
Thank you. Next question.
Hi, great talk today. Kevin Miller, State Center Community College District, and also Fresno Coalition for Digital Inclusion. We're building in the Fresno area a collaborative network started by a pilot with Fresno Unified School District. You may be familiar,
Very familiar with it.
4G, CBRS.
Right.
And starting to work on how we can tie that to other partners, potentially different cores, roaming between different cores, that sort of thing, more as a, internet of last resort.
Yep.
Curious how you guys are potentially looking at building those partnerships to get access where folks are unserved. And then also, other spectrum options, EBS, not super utilized right now. A lot of those leases are starting to come up.
UHF.
And are you guys looking at that spectrum a little bit longer wavelength, a little bit better penetration potentially into structures? Thank you.
Well, I would want some of the panelists to chime in on how to coordinate sort of on the some of the initiatives you have around Fresno. We, from Federated Wireless perspective, we do have a number of kind of community underserved digital divide projects where we can, because the nature of the technology is put the coverage, put the access where you want it. It's in your control. We have school districts, rural communities, resort communities, other all kinds of areas where access is provided in that way. Let's see, I think you're asking about other bands and
So again, what we're trying to do is get one right, go to the next, go to the next. So we're literally building a milestone chart of what frequency, who owns it next to be able to integrate. We then find who owns it, uses it, and builds the systems for it. And we bring them to the table. We use a process called a challenge process, which is where we go in and we bring them to the table. We tell them what our problem is and then work with them. We've been very successful for whatever reason. And we use the Cal Poly name a lot, which helps out in the state of California, honestly. Not bragging, just fact. And that helps people come to the table and we're a neutral experience so they can say, this is my problem and this is where I have shortfalls. And so we've seen that to be very successful. And many of those cases, those are Cal Poly grads that we're interacting with. And so they're really excited to come back for a couple of weeks or whatever. So again, it's about using our influence and the CSU influence to get to those entities. And I think using that CSU one will be even more powerful because that's the largest public education system. So why not use that as an influence element?
Yeah, there was a common theme. You touched on roaming, and you'll see on CSU, we have private sector, we have the national lab, and we've got the UC system. Stanford was almost here, so we almost ran the gamut. All of us in common have this vision of being able to roam across our institutions. What we're building together, we want to align on blueprints and some form of standard so that Andrew can come over here, pop on our network using his SIMs and working out how that can all work. And, Fresno Unified School District, you guys have been out there for a couple of years now too. So it'd be great to kind of pull you into that discussion.
Can I add a bit more on that one as well? The concept of federation is something that could be very valuable in this space. We've all seen how successful EduRoam has been over the years, and being able to apply that concept to another spectrum with a slightly different access technology. The protocols to get on the network are different with 5G versus Wi-Fi. But one of the things that we're trying to do is always simplify the experience for the end user. So there's two classes of end user that I see in what I'm trying to serve. There are the people who already have an authenticated identity with Verizon, AT&T, Sprint. And so the neutral host application is going to make it easier for me to deliver better services to those people. And then I don't have to worry about identity. That's all handled by the back end. But then there's another class of people. I mentioned a couple of applications where we might want to put devices on our network that we don't want to subscribe to any of those providers. So we want to create our own mechanism for authenticating internally to campus. And that's where you see the similarities to EduRoam. Right? We currently have our identity database. It's federated with EduRoam, and therefore it provides reciprocal services all over the place. If we could see that same result for 5G connected devices, there's a huge benefit down there.
Game changer. Thank you for your patience, sir. Next question.
Sure. I'm Tom DeFonte. I'm from the University of California, San Diego. We have a group that works with NYU that takes 5G radio and pushes it over programmable fiber to networks to NYU, it pops out the other end and vice versa. I don't know if that's interesting to you in terms of also collaborating. I know it took us a lot of work and equipment and time to set all that up, but it does work. And I offer our collaboration.
We're always interested in collaboration. And our approach to this is the more people we have at the table, the smarter the solution will be. And I come from the DoD side where risk reduction is huge. We're trying to do as much of that risk reduction, much like DARPA did before we go buy. I can't afford anymore to just buy something untested, unseen and say, yeah, it's going to work. And then it doesn't, because students are vocal. Parents are even more vocal. And it doesn't work in that modern world if it doesn't happen to make them happy. So we'd love to talk to you and follow up.
Okay. Andrew knows how to get to me too.
Yep. Absolutely. And of course, the answer is yes, Tom, of course.
Yeah,
Okay.
of course. Any other questions? All right, last question.
One
Thank
more.
you. One more.
My name is Kevin Riley. I'm from the Orange County Department of Education. I am a 5G dum-dum, and I had a discussion with you yesterday, and you said you were talking on 5G. I'm like, what's the big deal? But I see the application here. So I guess my question, oh, by the way, I have a solution for you. Mesh balloons. Just got to make sure there's no hurricanes.
So just real quick on that. One of the things that we're finding out here is the application of this private network, 5G, digital networking, and AI. Realize in today's world, every one of those individual sensors speaks its own machine language. And so what we're trying to look at, particularly in the ag tech, is what if I can take that machine language and now retrain it to speak the same language as all the other sensors? So that instead of having to buy a dashboard for a dashboard for a dashboard, I have one element, maybe even AI run, that supports that farm tech entity or that sensor collection. Or, I mean, the game changes significantly because of the technology.
Yeah, and I love the security aspect of it too. Offloading your IoT to this is a great idea. But you talked about documentation. How does a guy like me get involved and start learning about this?
Well, you have to volunteer to be in our consortium, and then we'll be glad to share with you whatever we've produced.
It's not open source yet.
Not yet.
Okay.
It's kind of open source to those we like.
Well, I can buy you a beer after.
You don't.
I know you like
that.
wine, so
Yeah.
I can buy you.
No, we definitely will be coming out with an announcement on the Alliance. Once you're in the Alliance, we will share with you everything. The idea is to be part of the Alliance. It's not a cost. It's you got to do something. You got to help us be successful. And so again, love to have you at the table.
Well, I think there's huge application in K-12 as well.
Totally.
Yeah.
Yeah, we believe, again, and I know Jonathan's going to stop me, but we believe, again, what happened was we got into the world where the telecoms vendors were selling a solution, not thinking about the problem. And what we're trying to really do is to prove the problem, the use case analysis, that you can shape what you're asking to have to do your job. You want to add to that?
No, just let's talk aerostats after this. So
Yeah.
I'm game.
Okay.
Yeah.
All right. Thanks.
Thank you all very much. We appreciate it. Hope it was useful and helpful. Thank you to the panel.